thanks for coming. So my name is Landry, and today I'm going to talk about geospatial development. So more specifically, I use the term geospatial because we're going to go beyond just maps. What a lot of times people think about geospatial, they think, oh, it's just all about the maps. In fact, one of the things I want to do today is go beyond those maps. All right, so my name is Landry. I'm a senior product manager at Infragistics. You guys familiar with Infragistics? Yes? Who was familiar, who actually knows that we have iOS controls, native iOS controls? No one, right? Well, now you know, we do. You can come talk to me at my booth afterwards. The reason why I'm mentioning this also is not just because we're at a conference like Xamarin Evolve, but also I'm the product manager for Nucleus, which are our iOS controls. I basically manage all of our mobile products. So quickly about me, so I've speaking at a lot of events. I've been doing this for a while. I specialize on a bunch of things. So to me, mobile and geospatial are my two primary loves. So doing a session on mobile geospatial was just like a perfect fit for me. That's why I'm really excited to come and talk to you about this. I'm actually an MVP on Windows Phone development. Kind of ironic, given that I'm doing a session primarily around iOS and Android. But it does reflect the reality of where we are today. This is 2013, and you can't really qualify yourself as saying like, oh, I'm a Windows Phone developer, or I'm an iOS developer, or I'm an Android developer. Truly, what you want to be able to say, and I think that's why you're here as well, is say, I'm a mobile developer. So today, it's going to be mostly about Android and iOS. I'm not really going to cover Windows Phone, just have a quick little thing about it, but that's not the purpose of my talk. You'll get all the materials for this, by the way. So the one thing you need to remember is activenic.net. That's my blog. So it's going to redirect you to my blog at Infragistics. And that's where I'll be posting the slides, probably sometime either later this week or early next week. And all the demos also I will be posting as well. So at least everything you'll see today, you will get the code for. You can also follow me on Twitter at activenic. There's some really loud music next door. It's probably Miguel doing his entrance again or something. I really appreciate you guys coming for this one. You can learn anywhere what's new in iOS. Okay, so some quick assumptions. I assume that you know some of the basics of Xamarin development, because I'm not really here to teach you those basics. So if you've seen the training, you're fine. If you've played with it a little, you're fine. But I'm not here really to answer a lot of the questions about how Xamarin's tools work. I'm going to focus on some specific niche areas, primarily around mapping, and then making REST calls to geospatial services and things like that. I also assume that you're a .NET developer, so that you already know CSharp. It could be VB.NET or F# as well, of course, that you know Visual Studio, maybe XAML in general. Not that I use XAML in this talk, but it fits your profile of who you are. It helps if you know mobile development sometimes on other platforms, but then again, we're all here to learn, so that's not a really big problem. I also assume that you know a bit about REST, like at least how to call them, maybe not. I'll be showing you some techniques here that are pretty easy on how you do this from any .NET platform, including Xamarin's iOS and Android. But I do assume that you don't know anything about GIS development, so that's pretty much my starting point. So if you're a mobile developer or you're starting in mobile, but you want to learn more about the mapping side of things, the geospatial side of things, that's what I'm going to cover today. So if you do know about GIS, there's some parts probably that will sound a bit familiar to you. For the iOS part, this is no secret. It's not just my rule. It's basically Apple's rule. You'll need a Mac, as you know already. So if you didn't catch that already, be prepared to get a Mac. And I also assume that you want to learn the cross-platform techniques and best practices on iOS and Android. And of course, all that stuff can be used on Windows 8 and Windows Phone as well. So I'm not here to talk about PhoneGap, and I'm also not here to tell you about how to design a good mobile app. That in itself is like a month of training. Okay, so I'm going to give you a very quick overview of the GIS world. Initially, I thought I had only 45 minutes for this talk based on the original schedule. Apparently, I have an hour, so that's going to give me a little more breathing room, so that's good. And we'll look at also why GIS matters for mobile developers and for mobile users. Then we'll start looking at a lot of different imagery options that you have on different platforms, because there's a lot of choices out there. It's not just about using the map kit on Apple and that's it. So we'll talk about some of those. And beyond maps, there's geospatial services we're going to explore. And then I'll give you a simple cross-platform demo. It's not rocket science, but it shows a lot of the key essentials that you need to master when you build an application that's going to be map-driven. And so my GIS is a very simple demo that I have on iOS and Android. I have a little prototype working on Windows Phone as well, because that was my starting point. And that's going to focus mostly on geocoding services as well, combined with mapping. And then hopefully at the end I'll have some time for Q&A. If not, I'm around until tomorrow afternoon, so you can come see me at the booth at Infragistics. So when we look at the mobile platform options, of course, when you think mobile developer, most people will usually think Apple, Android. Those are the two dominant platforms. To an extent, Windows is still a player. Windows Phone is actually growing. Windows 8 is gaining market share. BlackBerry is in a tough spot. So it's a bit of a tough situation. As a Xamarin developer, if we can call you that, as a Xamarin developer, of course, the primary platforms you'll be working on are iOS, Android, and Windows. But then there's also the big dilemma of HTML5. So this is more just a positioning slide. Of course, at a show like this one, everybody knows that we're not really covering the bottom part of the session, the slide here. The whole HTML5, mobile, hybrid, phone gap, and everything, it has a time and a place for certain scenarios. But I'm a personal believer that Xamarin's approach is actually the right one, kind of forcing you to rebuild your UI in your native application, but then trying to share as much code as possible. So for today, that's going to be my primary focus, are the two platforms on the left with a little bit of prototyping on Windows Phone as well. Okay, so let's give you a quick overview about GIS, because GIS is more than just about maps and using GPS, for example, to find you on a map. So what is GIS? So first of all, GIS stands for Geographic Information Systems, or some people will say Geospatial Information Systems. Think of it as software and sometimes even hardware, but primarily you can do a lot of with software today. It's software that will combine a lot of different technologies to achieve a goal. So it's software that's going to leverage maps, first of all. So the maps are going to be shown. They could be raster maps made from tiles, or they could be vector maps that are actually drawn in real time. You're going to need some imagery as well. So some services will give you satellite imagery or aerial imagery or hybrid imagery. Hybrid means where the satellite picture actually has labels on top of it. Then you've got a lot of things like data processing, geocoding. So these are all features that you can have in terms of taking your data and then working with that data. But that data is going to have a geospatial component attached to it. Geospatial component is nothing fancy. It simply means that either directly or indirectly, you can put that data on the map. You can associate a latitude and a longitude for it, or multiple latitudes and longitudes if it's an area that you're talking about. Then you've got additional services you're going to be working with, for example, like routing and directions, where to go from point A to point B. It's not necessarily a straight line. We're not birds. We don't fly. And even if you fly, you have to go to airports. So it's all about driving routes and then making sure that you fit within the streets. And of course, spatial data itself is a key component here. Spatial data doesn't just mean the data that has a latitude and longitude attached to it. It means any kind of data that maybe indirectly has a geospatial component. So a product could be geospatial data, because that product is made by a company, or it's manufactured somewhere, or it has an origin point. And the destination, also where it's going, if somebody buys that actual product, then that's another component that gives you geospatial, it's basically data that gives you geospatial components attached to it. That data, you're going to have to store it somewhere. So whenever you store it, you're going to have to put it in some kind of spatial storage. You can do it all manually, or you can use geospatial compliant databases for it. So things like SQL Server, SQL Azure, all have support for geospatial searches. So that means that you would be able to do a query, like something, for example, saying, I have a point that I've geocoded based on an address, and I want to find all the locations that fit within that radius, within the 3-mile radius, or within a bounding frame. So these kinds of queries are called geospatial queries. So for this, you're going to need some kind of engine that allows you to do this kind of search. Then ultimately, once you've stored your data in a database, and then you can do processing on it, you can geocode it, you can drive routes and everything, ultimately the system is supposed to do something that's going to be related to business. So that's where something like reporting and analytics fits into this. That's where it becomes very standard reporting or BI tools that you're going to be using for this. The only difference is that very often you're also going to have a map that's going to be part of that reporting, whether it's a static map or even if it's a dynamic map. And then finally, the last component is location services. This is where some hardware comes into play. Traditionally, it required a little more expensive hardware to do this. Now, we all have a GPS in our pocket. I still remember, because I was a Windows mobile user back in the day, because I've been an MVP for 9 years, so before that it was Windows Mobile, then Windows Phone, and I was so excited when that first phone, I think it was an HP phone, like one of the compacts basically had a GPS built in. And I was like, wow, this is unbelievable. When you think about it, we got a GPS on the phone. Now we all take it for granted, but if you grew up, with the phones and everything, you realize that how far we've come. I mean, in 2006, my wife would always get lost all the time. Whenever she would drive somewhere, she would get nervous. She was a wreck, Every time she had to drive in an area where she couldn't go, I bought her a GPS, like a Garmin GPS device to put in her car. That was one of the best gifts that I could have ever given her. And I've given her plenty of jewelry, trust me. Okay, but as a techie gift, because she's not a nerd at all, as a techie gift, that GPS device was unbelievable. Now, of course, she doesn't use it anymore. We got built-in GPS built in our cars. We have it on our smartphones. So location services is actually something that becomes a key tool because it could be to track assets or it could be for the users to position themselves and know what data they have around them. So why is GIS important? So in GIS circles, there's a statistic that runs around, and nobody has really been able to pinpoint what study it came from, but it's kind of something that's taken for granted in GIS circles, that there's about 70 to 80% of business data that has a geospatial component attached to it, whether it's direct or whether it's indirect. Whereas data, in the end, you can put it in tables, you can put it in grids, and yeah, grids are great. We sell a ton of them, so that's great. But there's more than grids in life, especially when you build a user interface. Sometimes that data belongs better on a map. So whether it's customer locations or supply chain, knowing where stuff is, or whether it's just plain social media, where users are out there and you want to be able to know where they are, or they want to know where they are, or what's around them, how they can interact with others. Geospatial components, people kind of expect them more and more as part of their applications, and I think that's why you're here. You want to learn a little more about how you can integrate this in your apps. So mobile is a natural extension of that because, of course, when you think about geospatial, you can think about a computer system, but ultimately the person would be sitting at a computer in an office, not moving from there. It makes a lot more sense on a mobile device where people are actually out there, they're in the field, and they're actually moving because it's all about location. If the location never changes, it's kind of boring. If the user and the data moves a lot, then you have a perfect scenario, and that's where mobile comes into play. We have access to better imagery today. People have new perspectives on things where they expect things to be on the map. And then you can actually personalize that mapping experience by showing them what's around them, what's relevant to them. And mobile devices now all have location services. They all have GPS chips. They're more powerful today. They're smarter devices as well. We already know how mobile devices are overtaking the PC, combined with tablets as well. When I talk about mobile, I also include tablets. I don't just mean smartphones. And then personal navigation devices are kind of a thing of the past now. More and more people will just go and install an app on it. It's kind of funny, though, how perceptions where you could say somebody would be willing to pay $200 for a dedicated GPS app. That's all it does. It just does GPS and maps and location. And yet, when they see in an app store a navigation software that's like $40, they go, $40? Well, that's because Angry Birds is $2 or $3, So when they see $40 for a software, they just go bananas because they're like, this is too much. But they forget that the device itself gives them already a lot of value. What you're paying for in that GPS very often was more the data than the actual hardware. And things like location-based advertisement using techniques like geofencing, for example, are becoming more and more popular. Geofencing is where you can actually identify a virtual area geographically, and if somebody crosses that area, they can trigger something in the device, in an app, and platforms like Android and iOS actually do support geofencing. It's a little beyond the purpose of this talk, but all the techniques you're learning here are the baseline for integrating this later. So as a developer, though, what is it that you care about? What is it that you need to know about? So you will need to know about your imagery, of course, so that we're going to talk about like how to choose mapping controls, what's available out there, what are the capabilities. You're going to care about things like geocoding and routing. As you can imagine, geocoding and routing are not things that are going to run just on your phone itself. Unless you have like a giant database, and it's kind of possible. Like for example, a lot of geospatial software now, like navigation software that you get from TomTom or Garmin on your Android or your iPhone or iOS device, or even Nokia Maps now has their own like offline maps. They can give you some kind of routing, but it requires like a crap load of information to be downloaded to the phone before you can actually use those services properly. Geocoding is the same thing. Geocoding, for those that don't know, and I'm going to be talking about this today to show you how you can do it. Geocoding is the process of taking an address and converting that into a latitude and a longitude. Because once you have a map, if you want to put a point on that map, you want to make sure that the point is not on the map controller itself, it's on the map. So when you move the map around and you zoom in, you zoom out, the point keeps staying exactly at the same coordinates. So latitudes and longitudes is basically what you'll be swimming with when you deal with geospatial apps. And geocoding allows you to take an address, a location, the name of a city, a famous landmark, and convert that to lat-longs. Reverse geocoding is the reverse process where you already know where you are, you have the lat-long. I mean, if I ask you right now, what's the lat-long where you're sitting right now? We have no idea. I mean, our phones can tell though. So that means you can technically ask your phone and say, hey, where am I now? And then the phone will be able to use reverse geocoding to tell you, well, you're actually in this city at the intersection of this and that, or the closest address is this. So reverse geocoding is converting a lat-long to an actual location that humans can recognize. Spatial search is something that's a little beyond this talk because it requires the database first, the data, and then after that, doing the searches. Data services, you're going to need data somewhere. Maybe it's your own data. Maybe the users will generate the data as they move around. So if you think of a running app, a running tracker, well, a running tracker, the app generates its own data itself. And then you're going to store the data either locally or in the cloud. So you're going to have to deal with data and data services. You're going to have to store it somewhere. And I got a typo there on the fast thing. That's not exactly what it was supposed to say. But it's more like global reach, actually, that it was supposed to say here. So the global reach is you want to make sure that your app is also going to work across the globe. You don't want something that's just going to be like US bound, because especially now, we have a means of publishing apps in dozens and even hundreds of countries right away. So, well, hundreds, let's just say 100 to 200 countries very easily. So you want to make sure that all of these users are going to be able to use it. Location services also is part of the developer story. So I'm going to be talking about some of them today, primarily the imagery side of things and the geocoding side of things. There's actually another session tomorrow, and I'll put a reference at the end, that Wally McClure is doing on maps on iOS and Android. And we talked to make sure that there's not too much overlap between our two sessions. There's going to be a little bit, but most of it is actually going to be different coverage. So you'll be able to go see his talk. He's going to talk more about location services and different map controls and things like that. Now, who are the key GIS players? Because there's a lot of companies that are making a lot of money with this. There's a lot of key players that you have to deal with. So if I ask you about mapping, what's the first mapping company that comes to mind? A lot of people will say, well, Google, because everybody uses Google Maps, right? That's true. Google Maps is by far the most popular mapping platform for consumers. However, for example, if I were to ask in the enterprise, you would actually find a lot more Bing Maps, and in government, you're going to find a lot more Esri. Esri is actually the top GIS player in the world. They have over 33% market share in solutions for GIS, for software, for servers, for cloud, for information, maps, and data. These guys are like the number one. Nokia Maps is rebranded around here. A lot of people wonder, like, why is Nokia Maps so important? Well, why do we even care about it? I mean, is it just like a Windows Phone thing? It's because a lot of people are not aware of, a few years ago, Nokia acquired this little company called Navteq. And Navteq, before Google entered the fray here, Navteq and, I forget the other one. It was not TomTom, it's the one that was acquired by TomTom. Anyways, TeleAtlas, yeah. So Navteq and TeleAtlas were the two companies that basically own virtually all geospatial data in the world for consumer access. So every device you were using, every GPS device got their data licensed either from Navteq or from TeleAtlas. There was a bit of a bidding war with stuff going along. Garmin was going to purchase them. Eventually, things settled. And by the way, Google Maps for years was using TeleAtlas data. So they had a multi-year agreement to use TeleAtlas data. Then eventually Google broke off, decided to manage their own data, acquire their own data with their vast resources. So Google became a player by not just being a technology consumer of data, but also managing their own data. And then Bing Maps, so Google has their own now. Bing Maps gets their data from Navteq, which means now it's Nokia. So a lot of people think that the Nokia-Microsoft relationship is all about Nokia going all in with Windows Phone. But there's also a reverse situation where Microsoft is all in with Nokia's map technology. So for those that wonder if Nokia is still going to be alive because Windows Phone only has a few % market share, I can assure you Nokia is doing very well, thank you very much, because Navteq is a huge money maker for them, because it's a massive platform that has a lot of data that generates a lot of revenue. Garmin, all of their data comes from Navteq and Nokia Maps. TomTom, they're mentioned here because they're the ones that ultimately acquired TeleAtlas. But as a developer, you're not going to care too much about TomTom because they don't really make their data available easily for developers. Well, with one exception, that's where Apple gets most of their data. Apple Maps, Apple doesn't create their own data themselves. They basically license a bunch of technologies. They acquired some companies as well for the core tech, the core software, but the core of their data comes from TomTom. So when you use Apple Maps, you're using TomTom data. Now, don't go and think that TomTom is not good because of the wonderful success of Apple Maps. Let's just put it in mild terms. It's more like the implementation that Apple did, and they've actually acknowledged it, because the last thing they wanted was to put a stain on TomTom's reputation with their data. It's actually the implementation that Apple did, and that's what Tim Cook apologized for. Then there's MapQuest, good old MapQuest. You guys remember MapQuest? Yeah, they're still around. They've modernized. They've got data, as far as I know. They get a lot of data. If I remember correctly, I'm trying to remember if they get it from Nokia Maps or TeleAtlas or TomTom. Can't remember exactly, but they also work with OpenStreet as well. OpenStreet is an open source project. So this is basically crowdsourcing location data where people could contribute, not just like open source is all about contributing code, while open source crowdsourcing mapping is basically contributing location information so that they could build a network of maps and information around the world without necessarily having an expensive infrastructure. And of course, the quality is so-so. Some places it's great, some places it's not, but the beauty of it is that it's free. So as a developer, that sometimes can be an interesting option because if it's free, it could be a good entry point, especially if you don't want to afford like some of the other mapping services. So where does that leave us? So that means in a mobile application, and don't worry, I've got plenty of demos coming into this. You're going to have to choose to put a map control in there. So let me just help you to read this table here. So this is showing some of the key map providers here. You'll notice TomTom is not here because they don't directly provide controls. Apple Maps is here. And then the 4 key platforms on mobile that are iOS, Android, Windows 8, and Windows Phone. And by Windows 8, we mean the tablet side of things. We can see that there's 2 colors that are used here. So first of all, who has what? If something is green, it's considered to be the expected platform, the expected mapping platform on that mobile device. So that's why, for example, on iOS, Google is just as home. Google feels just as home as it does on Android as it does on iOS, because Google was the main platform for the map kit for years. It was the key app that people were using. So using Google on an iOS device still feels normal. Of course, Google Maps, being Google technology, feels right at home on Android. It's kind of a given. On Windows Phone, you can kind of fake it. On Windows 8, you can kind of fake it because with WinJS, you could leverage some of the Ajax controls from Google. But then it would just be on WinJS, and it's not a perfect implementation. On Windows Phone, there's nothing native. Somebody has created like their own app to put Google as an app on the phone, but there's no actual control you can use. You would have to yourself create something custom, and there's no easy SDK that you can use. Bing Maps, of course, very at home in the Microsoft world. There are some old implementations that Microsoft created. There's an old control from 2010, I think, that Microsoft created for iOS, but it's not been supported, it's not been upgraded. There's an open source project on Codeplex on how to use Android maps, but it's more of a JavaScript wrapper, or rather a native wrapper around the JavaScript version, and it's also an old version. So we can't really say that that Bing Maps feels really at home on iOS and Android. Why is this important, by the way? Because when you're building a cross-platform mobile app, you're going to be in 2 kinds of scenarios. if you're building a consumer application, the consumer app, of course, has to fit at home, to feel at home on the device. So that's where picking a mapping platform that users will expect and appreciate is very important. So if they're using MapKit with Apple Maps every day or Google Maps before or on Android, then things like Google, of course, are going to feel more natural. You want to make sure that you pick something that's going to feel at home on that device. You're not going to try to shoehorn a technology that people are going to wonder, like, why am I seeing Bing on Android, you know? And then, inversely, if you're creating, and that's where it's important, if you're creating enterprise apps, that's where sometimes you're going to have the same pool of users, especially with bring your own device, where people, some of them will use iOS, some of them will use Android, some of them will use Windows 8, Windows Phone, so they can use anything. That's where you need to have a certain consistency, where if you have one mapping platform at one place, another mapping platform at another place, then suddenly it's going to feel weird because people might collaborate with each other. One employee might talk to another employee, and they're using their own devices, but they're not getting similar results on their phones or their devices because one of them is using the geocoder from Google and the other one is using the geocoder from Bing. You would assume, of course, that all geocoders work perfectly and they always return exactly the same thing. But we all know of locations where Google works better and other locations where Bing Maps works better, and so on. So that's why, depending if you're consumer and if you're enterprise, and most of the times I assume some of you will work on both, it's important that you can pick the right technology to go on your mobile platform. Nokia Maps, of course, well, okay, Esri first. So Esri is pretty much like a very good situation. They support a lot of platform. Esri makes their money on the servers, so when you look at the way that they support like a lot of different platforms, yes, they have a native SDK for iOS. Yes, they have a native SDK for Android. And they actually have a beta right now for Windows 8, so you can build Windows Store, WinRT apps. And then, finally, Windows Phone, they also have support for that as well. They have a few more. They have Adobe Flex, Flash, there's a JavaScript control. So they have a lot of different controls that are supported. And Esri, unfortunately, though, there's two problems here. First of all, it's not really free because it's a really premium offering. So usually it's mostly large corporations, governments that will use them. There's some stuff you can use for free. And I have a few links for that at the end. But the other problem, and that's where I have my second little thing there, XB, means that you have Xamarin bindings for those. Because of course, if you're a Xamarin developer, you care about using a library that you can natively import in your Xamarin projects. So you can't just use any native library very easily. Yeah, sure, you could create your own bindings, but that's a lot of work, especially if you want bindings that will feel natural, that are not just a pure compatibility layer. So I personally prefer to use official bindings that are provided by a company rather than trying to create my own. So sadly, Esri doesn't have anything there. I know they're thinking about it. Esri is actually an Infragistics partner. We're talking to them, and I can tell you that it's something they're considering and they're looking at it. So if you see Esri scenarios that would work well for you, let them know. If they get more pressure from the market, it's something that might come. Nokia Maps is purely a Windows Phone thing. Apple Maps is purely an iOS thing, so there's bindings for that as well. OpenStreet that's where it's a little hard, because OpenStreet is purely a web technology. They don't really have controls for it. So for example, at Infragistics, we have advanced controls that we make for Silverlight and WPF and jQuery, and we have a map control. Where using our controls, you can actually easily integrate them in your apps for WPF, Silverlight, HTML5, and they do support OpenStreet. We don't have the mobile version yet. That's another thing I can tell you we're working on. It's on my list. But today, if you want to do OpenStreet on iOS, MapQuest actually has an SDK for it. And since MapQuest supports OpenStreet, then technically you could use both MapQuest and OpenStreet on iOS and Android. So where does that leave us? So that leaves us where, first of all, the easy solutions where we don't have to jump through a lot of hoops to code things. It leaves us with Google Maps and with Apple Maps. On Android, it's a no-brainer. It's going to be Google. On Apple, on iOS, well, you can go either way. You can go Google or you can do Android, or you can do Apple. So in this session, I'm actually going to focus more on the Google SDK. And whereas the map kit from Apple Maps, if you want to know more about this one, tomorrow, Wally McClure will actually cover it in this session. So you get to see both of them. So in reaching that decision, though, like why why would you use Apple Maps on the iOS side of things, of course? Why would you use Apple Maps versus Google Maps in terms of the SDK? Google Maps used to be the technology on iOS, but of course, it was the map kit. So the map kit is an API created by Apple. The data came from Google. Now, they replaced the data source with Apple Maps, which is a combination of things from TomTom and others, but the map kit itself is still the same API. So that's why if you were using an application built with the map kit before on iOS, it's still going to work with iOS 6 and up that is now based on Apple Maps. So if we look at both sides of things, we got Google Maps and we've got Apple Maps. There's pros and cons on both sides. It's not all good for Google and all bad for Apple, trust me. And sometimes, some scenarios, you will reach the conclusion that it's better to use Google on iOS. Other times, you'll reach the conclusion that you better use Apple. There's a link at the bottom there. By the way, there's a great article because this company has created like some advanced map-based applications for iOS, and they've shared a lot of their findings and their studies with both of the technologies. So if you want to read the article, I've put the link at the bottom there. So first of all, if we look at the Google side of things, well, one of the pro sides, of course, is it's Google data. Google Maps is a very, very mature set of data. The maps are mature. They're very extensive. They have better hybrid and satellite imagery. They do have 3D buildings that are supported. And there are some scenarios, like, for example, on the Apple Maps side of things, the data is good, but it's Apple's implementation that's not mature. If you look at how they create hybrid maps, for example, Google uses semi-transparent roads on top of the maps, whereas on Apple Maps, the roads are actually opaque. So sometimes it makes it hard to see the actual imagery under those maps. So it's a quality issue. You can rotate and tilt the map very easily. There's a whole camera system, but there's no tile overlays. So let's say you want to create your own, on Google side, let's say you want to create your own tile set of data. So if you have a custom tile set, you want to add on top of it to create your own layer, you actually can't do it on Apple, but you can on Google, but you actually can on Apple Maps. On Google, you could put an image at a specific location and it's going to stay there, but you can't create an actual quad key of tiles and overlay it directly in the app. You have a lot of advanced features. There's a location search API that's open. Everything is also free here. There's no quotas. Since Apple only makes it available to iOS devices and developers, then they're not putting any quotas on how many geocodes you can make, how many calls to the maps, whereas on Google Maps, there are some quotas, and I have a slide about those after my demos. You have some advanced APIs you can use for geocoding, directions, places. It's going to be very consistent between iOS and Android as well, whereas if you go with Apple Maps, you're going to have a different experience on both sides. The quotas, of course, can make things a little more expensive, and one of the problems with using Google Maps is because it's not part of the native SDK, it's actually going to increase your app size. So it's been observed that if you integrate Google Maps SDK in your iOS project, you're probably going to end up with an app bundle that's going to be anywhere from 2 to 6 megabytes larger. So Google's working on that. It's something. But of course, on Apple Maps, it's not a problem because it's part of the base SDK. So there's no increase, really, other than using a normal control. So the data is good on one side, but the SDK is better on the other. The map kit is actually very mature. It's been there since iOS v1. So the map kit itself it works very well. People know how it works. There's a lot of resources as well out there. So there's a bigger community of people that are familiar with it. Whereas the Google SDK, it's fairly new. It just came out, like first beta was in December, and then it's been available since February, I think, and then there's been a few updates. But that's the cool thing, though, is Apple can actually rev theirs a lot, Google can rev theirs a lot faster, whereas Apple, they're kind of limited to updating the map kit whenever they drop a new version of iOS. So it's like once a year only. Whereas Google, I think they've already done 6 updates on it since it came out. So you can expect probably Google to catch up on the SDK quality. And I can assure you it's a lot easier to build a better SDK than to fix issues with the data source itself. And right now, Apple Maps, that's where a lot of their issues are, is with the quality of their technology and in terms of the data in the back end. So if we look at a simple solution design like this, imagine that you're supporting iOS, Android, and Windows Phone, then you could standardize around Google Maps as your provider for iOS and Android, and then for Windows Phone, you could use something like Nokia and Bing Maps but the location data would all be the same. So in this demo here, I'm going to show you iOS and Android with Google Maps, both from an imagery, but also a geocoding point of view. So I'm going to show you a simple demo, show you how it works. Right. So I have an iPad running here. I'm running the app natively because the whole integration between a Mac and a Windows box right now requires the network, and the hotel network is just so not compatible with this infrastructure right now. So I basically have the app already deployed on this, and I'll show you the code after that I've built. I've actually built it all in with Visual Studio and then deployed it via a Mac. But for this part, I'm skipping the map, the Mac to show you the app natively. So if I go to my GIS here, so again, this is dependent on the network. So what I'm using here is an app that has the Google Maps SDK that is used. So the maps that you see are actually Google Maps. And then it's a very simple application. There's nothing on the other two tabs at the bottom. It's more, actually, you can't see them on the display here. But it's actually a tabbed application. But there's only one tab that has data. And sadly, I have a text box at the top, but you can't see it. Let me see if I rotate. Well, it's just a text box, a text field, and I keep losing my connection here. There we go. All right, so what I have here is I can switch between map views, so I could go hybrid, and then or satellite. Actually, they're inverted here. So this is satellite, and this is hybrid. Hybrid actually has the labels on it. So now I'll just zoom out to North America like this. And then here at the top, I'm just going to do an entry. You can't see it, but I'm just going to type an address. That's my old office in Manhattan. It was actually at 291 Broadway, Manhattan, New York. All right. And then I have a button here at the top, and I'm going to click Geocode. And when I click Geocode, it actually calls the geocoding service at Google. And then it puts a nice little pin on my map, so you can see it here. I'm going to switch back to road view. And then I can go and zoom in. And because it's Google Maps, it's gorgeous. You'll see now it looks nice, but then look at the Google Maps controller when you zoom in, what happens? Boom. You go full 3D. And then the cool thing is it actually supports tilt. So I can use 2 fingers to actually tilt my map. And then I can even rotate my map if I want. So it looks a little jittery on screen there, but trust me, on my iPad, it's like super butter smooth. And I can still tap my push pin to see the custom pin that I've inserted. Okay? So there's 2 key things here. There's the map control itself, and then there's the integration with the geocoder to make the call. So I have the same thing running on Android. So let me first show you how this is built on iOS in Visual Studio, and then we can explore how to do it on Android. So for this, I actually use Visual Studio. So there's 2 things here. First, there's integrating the Google Maps SDK on iOS, and the beauty is that Google has provided one, Xamarin has some bindings for it. I don't know who created the bindings. Is it Google Maps or is it Xamarin? But the bindings were great. And you can actually just add it from the component store. So if you, from Xamarin Studio or from Visual Studio, you can just say, I want to add a new component, browse around the component store, and then you can add a Google SDK from there. The first thing that I wanted to do, though, is it's all about code sharing, right? So what code can I really share here? So the map control itself is going to be kind of proprietary to each platform because there's an SDK for Android, for Google Maps on Android. There's an SDK for iOS. And then on Windows Phone, of course, I would use something probably like Bing Maps or the new Nokia Maps control that's on Windows Phone 8. But the key thing that I wanted to reuse here was my geocoding call. Because for the geocoder, I actually have to call a REST service at Google. And then with that REST service, I simply want to call it asynchronously, and then whenever I get my results, I want to raise an event. And all that code, that's the code I would like to reuse. So how do I do this? So I have this nice little piece of code, and what I did first is just to truly test the power of the cross-platform thing, I built the whole thing in Windows Phone first. So since Windows Phone is I would say, the platform I'm most comfortable with, that's simply what I did. I created it, and then I created this class. So here's how it works. So first of all, it uses JSON, the JSON.NET library from Newtonsoft. You guys know about this one? Who doesn't know about this library? Okay, it's really awesome. You should definitely try it, and I'll show you how it works. And there's also another cool trick on how to integrate this to parse your JSON calls. So I use this in my project. This is also a library that's available from the Xamarin store. So that means you can easily add it. So for the Windows Phone 8 project, I just went via NuGet. I added JSON.NET. And for Android and iOS, I simply did add new component from the Xamarin store, and then automatically got this library. So I created my own namespace for it because that's the same namespace I'm going to use the other two projects. So it's my class is reused as activenic.gis.google Maps. And then I've got this class called the Google Maps Geocoder that I created. So the key components here that we first have to focus on is how to geocode something. So the first thing is the results you're going to get. So let's see at the order in which you would be doing things. The first thing you need to know is what is the API that you're calling. This is the JSON call, the REST call. So it's going to be maps.googleapis.com/map/API/geocode JSON address equals something, and then sensor equals true. This is simply a statement that you have to put in either false or true, depending on if you're making the call from a device that has a location sensor or not. I think it's an information thing. I haven't really seen it fail or something, but so what I'm going to do is I'm just going to copy this beautiful little string here, okay? And I'm going to copy this. So what would you do here? You would go and let's open a browser window. And then I'm going to paste this in here, but I'm going to go edit it to put something a little more meaningful. So address is going to be like, I'm just going to put something simple for now. I'm just going to put Manhattan, New York. Of course, when you do geocoding, you can either go very general, like a country or a state, or you can go more precise, like city or an actual address. So the more information you give, the more accurate your geocoding call is going to be. Now, of course, this is JSON. I can't really parse JSON with my naked eyes. So what I'm going to do is just temporarily, I'm just going to say XML on this. Okay? I'm going to copy this string so I keep it. And then if I run this, this is what I get. So this is what my response would look like. So I made the call to the Google Geocoder, Manhattan, New York, okay? And then down here, this is the information I'm interested in. The geometry, latitude, and longitude, and the location right here. And then location type is approximate, because of course, I'm talking strictly about the city center of Manhattan. It's not a very precise location. It could be anywhere in Manhattan I'm interested in, okay? So that's the key part I'm interested in. Now, how do you parse this stuff, you know, yourself without any problem? So this is where it gets a lot of fun. Who's familiar with JSON to C#? Few of you. Okay, the others are going to love this. So you just go to, I can never remember it's JSON to C# like this. Yeah, there you go. So it's basically JSON to CSharp.com. I should be able to remember this. It's pretty easy. What this does is if you need to deserialize JSON classes and put them into C# classes that you can use in your object model, this beautiful little website takes any JSON input, whether it's the actual JSON code or a URL that returns JSON data, and then it will automatically give you the C# classes that you need. So what I'm going to do is paste this in here. Of course, now I don't want XML. I want JSON. So I'm just going to change this. These are the two formats that can be returned. It doesn't matter what data you put in, because whether it's Manhattan or Microsoft or Hyatt or whatever, the format is still going to be the same. So it's parsing just the structure like this, and I say generate, and then boom, I get nice classes. So if you want to see what they look like, you click copy, and then you see them in a nice way right here that you can copy paste. So you see address component, northeast, southwest, bounds, location, northeast 2, southwest 2, viewport, geometry, and that's your that's the public class result. And then the root object. The root object you'll be able to rename to whatever you want. You can't rename the other ones though, unless of course you add attributes to change the way deserialization is going to work. So you just copy paste this, you just copy it, and then right here in my code, that's what I have at the top of my geocoder class, right here. So you see I've got my address component, location, northeast, southwest, viewport, geometry, result, and then Gmaps geocoder response. So I just had to drop this in here. Now, how do I make the actual JSON call? It's dead simple. So my geocode method, that's the main method. the geocode method right here, that's the key one that you're going to call in this class. Okay, it's getting loud now. Thanks. And then, so that's my string right here that I'm going to call. The address is the one from the text field, that I'm basically the one that I'm receiving here. And then I create a new web client, and then I make an async call. In this case, I can't really do I wanted to initially to use the async task, but since it's not fully supported yet in Xamarin, and it's also not supported on the Windows Phone 8, you can do async, but you can't do async tasks. So for this one, all I did is I simply create a new event where I say when the download string is completed, you're simply going to fire off this handler right here. And then I simply call download string async new URI with my geocoding URL. All right? You would normally handle this stuff. This is to do. If you've seen the Hanselman's call talk, you understand what I mean. And then once I want to receive my results, this is my geocoding completed. I check to make sure that I'm not null. And then the beauty of JSON.NET is right here. I'll just have to do gmaps geocoder response. That's the root object that I got. I renamed it to gmaps geocoder response. So I simply say response equal JSON convert.deserialize object. And then I cast this into a gmaps geocoder response, and I simply parse the e.results. In one line of code, I've actually taken my JSON response, and then I've deserialized it into a nice object structure that I did not even have to type myself because JSON to C# gave it to me. So the combination of JSON.NET and JSON to C#, and you can use this, by the way, for any JSON call you make. So this is not just for geocoding or stuff like that. Anytime you have to call a REST service that returns JSON data, you can use this. It's wonderful. And then I can go and dig around my response. I check, there's a status in there. I can see if it's OK. That's an actual string that's in the response. And then I can check to see my results if the count is greater than 0. Because, of course, this is a geocoding API. So if you say, for example, I want you to geocode Springfield, you're going to get quite a few results because there's more than one location in the US that's called Springfield. I think virtually every state has one. So this is getting a little loud, I'm sorry. So every state has a Springfield. That's why the Simpsons are actually in Springfield, because you can never know exactly where it is in the US. And for years, they've kept us hanging. We still don't know. I think that'd be the biggest reveal for the finale, to learn which Springfield it is. And then what I do is I simply go and check my geometry in there to make sure it's not null. And then all I do here is I simply raise an event. So I'm not going to show you the event in class. This is standard C# code. My class, since I couldn't use the async, in order to not put any platform-specific code in there, my class, when it's done geocoding, it raises an event so that any client application can then register for that event to receive the geocoding results. So what I did first is I built the Windows Phone version of this. And the Windows Phone version is actually quite simple. I did not even bother putting a map in there because the point of this session was not to show you how to build Windows Phone apps. I was basically just putting a simple thing where I have a button when eventually the designer shows up. Okay, so I have a nice little Windows Phone project here where I put in a text, I pre-populate it here, I geocode, and then I get my results down here. Okay, so it's as simple as that. And in terms of the implementation for this, all I do is I simply add my ActiveNix GIS Google Maps namespace, Google Maps geocoder, and then I initialize my geocoder. I register an event for it, and I say when geocoding is completed, I want to register this event right here, go to Google Maps geocoding completed, and then when Google Maps geocoding is completed, I simply go and extract the location out of there. For this, I actually take the first result. I assume that if I got multiple results in my collection of geocoding, basically entries, I assume the first one should be the more precise. Normally, what you would do is you can provide what we call a disambiguation box. So where if you get more than one result, what you can do is simply pop the results for the user and say, did you mean one of those locations? And then they can look at the various results and say, oh yeah, that's the one I need. They click it, and then that's the one you use because you have a latitude and longitude for all of them. Okay? So I show my results in the text string. So just to show you what it looks like on Windows Phone, I'm just going to debug a new instance on Windows Phone emulator here. So it's going to deploy. Launching task host failed. I don't know why it failed. Sorry? Oh, there we go. Oh, because it's trying to launch some, oh, because it's trying to debug on the iPhone here, that's why. Anyways, I'm just going to launch the version that I have here. It's right here, Mobile GIS, the Windows Phone 8. I call it Geocode, the event pops, and then boom, I get my lat long back. So I know my service works, okay? So that's the beauty of it. I built it with .NET and Visual Studio. I'm all fine. Now I want to use this in iOS. So I'm going to kill the Windows Phone emulator here. And all right. Now let's close this. On iOS, in terms of building the UI, I'm not really going to show you how the UI was built. I basically built the whole UI programmatically in this one. So I'm going to close this XAML here. What I did is right here, I linked in my iOS project to the exact same file. So I created the file first in the Windows Phone project. Then I removed that file from the project. I moved it to a mobilegis.core folder, which is common in the same parent folder as the mobilegis.windows phone and the mobilegis.ios and .android. And okay, let's terminate whatever this is. Yes, terminate the remote session, whatever that was. And then I simply linked it in both projects, and automatically it works. So this code, simply added it to my iOS project, didn't have to change anything. And then in iOS, so first of all, I've got my app delegate right here. So you'll notice I'm in my components, I'm using Google Maps and JSON.NET. I'm actually not doing anything with Xamarin.mobile right now, so it's not really needed. And then it shows up in my references here. Okay? And then in my app delegate right here, so I've got the Maps API key. This is actually a key for the Maps control itself. Because to use the map control with Google, you're actually going to have to get a key. So for this, you go to the Google console, the Google API's console on the web. And I have a link in the deck, by the way. And then what you do is you create a new project. Once you create your project, you have to say which services you're going to use inside of that project. So right now, the stuff I've enabled are things like Google Maps for Android, Google Maps API v3, coordinate, geolocation. That's the one you need to call the geocoder. Google Maps SDK for iOS, you need that. And then a Google Play Android Developer API. So this is my one project, and then I have to create a bunch of keys for it. So in my API access, right here, you, first of all, you have to create a key. So you say create a new iOS key, and then it's simply going to ask you for your app bundle. So your bundle identifier. So for example, com.infragistics.mygis, okay? So you put it in here. So this way it knows when the bundle calls it, it knows that it's actually that same application that's using that key. And then it generates a key for you. And then once I get that key right here, I go and add it as my Maps API key. So no pictures, please. I better change it afterwards. And then I have a map services that is right here. There's an object where I say provide API key. So at this point, every time I use a map control, the map services knows which key to use so that I'm allowed to actually pull imagery. So if you put the map view control directly in your view and then you launch it, it runs, but you see no tiles. There's no imagery. You have a key problem. So either the key has not been set or you have a wrong key or something like that. Go check your key. Make sure the proper services are enabled on it. Okay? Then I have a map view controller. So this is the same code you've seen. I have a map view controller that the code is actually not too complicated. So I have my map view, my toolbar, my text field, a segmented control to switch between views. Same code here. I simply create a new Google Maps geocoder, and I say Google Maps.geocoding completed equals this event handler. So actually that code, I didn't even write it myself. I was so lazy. I went and I copy-pasted the one from Windows Phone, and I put it directly in this one here. It works, no problem. Then all I had to do was create a new geocoder right here. My handler is down here. Google Maps geocoding completed. And then same thing. I extract my location. Again, same code. And then on the map view, I simply say animate to location. Then you have to create a location coordinate 2D object. That's part of the iOS SDK. And I simply pass in the lat and the long for both. And then I create a marker for this one. So first I position the map on it. Then I create a marker. And my marker is what's going to show up so I can tap on it directly on the map. So I create a new marker options. The position is my lat long. The title is custom pin. The snippet, that's basically the text that goes inside of that pop-up. You can put whatever you want in there. In this case, I just went and I asked for the full formatted address that I got back from the geocoder, and that's what I'm putting here. And then on my map, I simply add a marker to it. In terms of the initialization of the map, it's actually not too complicated itself. So there's a bunch of UI code here because I'm not using the interface builder with this. I built the whole thing in Visual Studio. So I could not use interface builder. So there's no zip file, there's no storyboard file. It's all built in the view controller itself. So that's my toolbar code. That's my toolbar buttons with my geocoder right here. And my geocoder simply calls geocode button click right here. And then that's my Google Maps control. So to initialize the Google Maps control, all I did is I first create a new camera. So imagine that the Google Maps control is in 3D, and you have a surface, and you have a camera looking at it, and you can actually tilt down, tilt up, and then you can rotate the camera as well to see the view. So you create that camera object, and then you say from camera. In this case, I centered it in the center of the United States. That's the actual coordinates of the geo center of the United States. You can Google it if you're looking for it. Zoom 4 is because you can have zoom levels. Zoom 1 is the widest view for the entire Earth. Zoom 16 or 18 is going to go all the way down. Not all areas support that level of zoom. So don't set like 18 or 17. Try to add exception handling for it because you might ask a zoom level that's not available, and either there's not going to be any map data, some controls can throw errors. Then I create a map view from the camera, and I set my frame based on the bounds of my UI. I make sure that it's resizable. I also enable my location enabled because it's automatically going to put a little blue dot on the map at your location. You can do more advanced work, and Wally is actually going to cover this in this session tomorrow to use more advanced location services. But at the very least, the map control, you can just say my location enabled equals true, and it's automatically going to center on, not center, but it's going to put a blue dot at your location. And then I finally add my map view to, as a sub-view of my main view controller. Then finally here, what I have is segmented buttons. And on my segmented display, if I change the value, it's simply a matter of saying map types equals satellite, map type equal hybrid on this one. So 0, 1, 2. I simply check to see which of my 3 segmented buttons, and I can just go and change it directly on the map view. For the Android version, because I'm running out of time here, I want to show it to you. Besides, you'll get the code, you'll be able to play with it. For the Android version, the integration you would think it would be simpler, but it was actually harder. It was harder because, first of all, there's a new API that Google has published. So most of the Xamarin documentation on maps is around the Google Android API v1. Sadly, that API has been deprecated in March. So you are no longer able to generate new keys for that API. You have to use the Google Maps Android API v2. But the problem is that API actually requires Google Play services to be on the device. It's those services that are available for developers so that they can easily integrate with Google Maps, with Google Plus, and things like that. And for the users on their device, that's what provides a lot of the auto updates that are done on apps. The problem with, though, is that Google Play services can't run in an emulator. There are some hacks that people have published, but it requires pirating software and running some weird stuff, and I don't believe in piracy or hacks. So that means that to do development on the Android SDK for Google Maps, you need a physical device. Otherwise, your map is not going to work. You're going to try to run it in an emulator, and it's going to say Google Play services are missing. Okay, so for this one here, what I did is instead of building a brand new app, Xamarin has not updated their documentation, but they have provided an SDK sample for the Google Maps v2 API. So you can actually find that directly via their documentation when you go into Maps and Location. I took that sample and I just tweaked it a little bit to support my geocoding. So I used the same map infrastructure in there. The key is actually going to be a little bit of a problem as well, because instead of simply getting an API key that you put in here, in order to generate that key, you need to have your SHA-1 fingerprint, which is attached to either your developer account as a debugger or to the actual release version. So typically, each app is going to have a different key store, key per app. And let me just show you where to find this. So in order to get this, what you would have to do is to go into your, so C, and then I go down into users, then that's my user right here, app data, local, and then you go into Xamarin, mono for Android, and then you get your debug.keystore, okay? And then the way you find out about this is when you go to that Google console, API console, if you try to create a new Android key, it's going to say, I need your SHA1 fingerprint in here. So to generate this, you have to run key tool -list -keystore blah 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 with mystore.keystore. In this case, it's debug.keystore. So in debug time, you can just use your debug fingerprint, but at release time, when you create a release version, a release build of your app, then you would use that keystore instead, so that each app would get their own signature. Otherwise, you're all going to go against the same quota, so make sure that you use one per app. So if I come here, I'm just going to copy that string right here. I'm going to say Windows run command, okay? Go up, and then I'm going to move down to that folder right here, and then it was called SHA1 fingerprint.bat. So SHA1 fingerprint, I'm going to run it. Then it's going to ask me for my key password. You could hard code the password in there if you want. The default password is Android. Enter. And then this is the string you get back. So then what you do is you use this wonderful mark tool in the console, and you want the SHA1 fingerprint, and then you press enter to copy it. Don't try to right click, it won't work. You have to press enter. And then this is what you're going to paste in here to generate your Android key. And then once your Android key has been generated, you get your key for Android apps right here. So that's the key that you will copy. And inside of your Android project, in this case I use Xamarin Studio for this one, you're going to come to your project properties under the Android manifest.xml. And then down here, this is where you're going to insert that key where it says Android labeled and then metadata, Android name, com.google.android.maps v2 API key. This is where you come and paste that value in your project. Once you've done this, now your application can safely use the Google SDK for maps. The other thing, though, is that sample, and that's where it's a good starting point for you guys to learn it, is that Xamarin sample also comes with Google Play Services. Because since Google Play Services is part of the dependencies of your project, you need to add it as a reference. Unfortunately, Xamarin is not allowed to reship that SDK and to create bindings for it. So what they've done is they've created this project right here, and this project will actually create the binding dynamically at runtime for this, but you're going to have to first copy-paste a whole folder structure from your Google SDK into a subfolder of that project right here, and they have instructions for it in the sample, so I'm not going to be able to reproduce the whole thing here. So other than that, what I have is a sample map activity, and it's basically the exact same code. So I've got my ActiveNIC GIS Google Maps right here. I have a link to that file. You can see here it's an actual link. And then what I do here, these are just like artifacts from the sample that I'm not using. I set up a geocoding button in there, and then this actually uses fragments. So the new map, the V2 API, actually use map fragments. The map fragments are basically to fragments what the map view is to views on Android. So you can learn more about fragments over here, but you don't have to worry too much about it. And then what I do here is I set up my geocoding button, and it's the exact same code. Geocode, what I do is first find by view to get my button, my edit address. And then when it's clicked, I simply called gcmaps.geocode with the address text field. To get my results back, it's going to be the same structure here, the same handler, Google Maps geocoding completed. I make sure my response is not null. I extract the location again, and then I create a new position, which is based on a new lat long. And then to move my camera to the new location, I simply create a new camera update factory at this new lat long position. And then here's where it's really important, because since most platforms, including Android, are not thread safe, if I try to just run this by animating the map, because that handler is running on a separate thread, it's going to fail. The call is going to be made, and it's never going to come back. So when you try to step through it, it's going to go, and then it won't move. So what you actually have to use is run on UI thread, which is kind of the equivalent of dispatch on .NET. And then you simply call map.animateCamera to this. You can either do a move camera, which will jump directly to that one, or you can do a nice animate camera, where if you have a good connection, the tiles are actually going to refresh fast enough to actually see the whole animation. But otherwise, when you run it on a device, especially with this hotel connection, you'll see that you don't see that. Then I create a new marker options. I set the position, set the title, set the snippet again to the formatted address, and then again with run on UI thread, I add the marker to my map. All right, so to see the final result on this, so I'm just going to run the final app right here. So is it going to focus a little? It's kind of hard to see. There's a few buttons here at the top. One of them is called Show Map Activity. This UI is not going to win design awards, I can tell you that. It's very basic. And I'm going to go and geocode my same address, 291 Broadway. Whoops, Manhattan, New York. All right, and click done on this. And then, oh, you can actually see the buttons now. That's cool. And then I'm going to say geocode address. And then it's going to jump. Of course, the maps didn't have time to refresh because they're not cached or anything. But now I'm in New York. And I can see my little push pin. Actually, I might zoom that all the way in. Yeah, I think I'm at the maximum zoom level right now that's been configured. Because you can configure the maximum zoom level, but I can tap on my little push pin right here to see it on screen. All right, so that's how the exact same code that I was using for geocoding has been used on Windows Phone, on iOS, on Android. In this case, it was just geocoding code. But if you're building a GIS application, you're probably going to have some routing code. And you're going to have a thick infrastructure also to get your data, for example, from the cloud or maybe from a database or things like that. All of that code can be reused. After that, learning how to interact with a map, display a map, show some routes, push pins, areas, and things like that, that's the easy stuff. It's all just UI code, and you get a nice native experience. So the Google Maps SDK for iOS, to get it, you go to that page there. Because on the Xamarin store, they have a little getting started section, but it doesn't really give you a lot of stuff. So you're going to have to go to the official documentation, and that's where all the code samples are actually using Objective-C. So I've always said that even if though Xamarin gives us like really amazing tools to use CSharp, if you're going to use a platform and build for it, sooner or later you're going to have to at least be able to read the language of that platform. So if you don't know Objective-C, at least try to learn enough to understand how it works, because you will have to interpret how Objective-C works and then figure out how to write it in C# sometimes. It gives you different views for normal, satellite, hybrid, topographic. You can scroll, pan, zoom, rotate, tilt. You can programmatically control the map camera. I've already demonstrated this. You can add markers, but you can also put little info windows, polylines, overlays, just images though, not entire tile overlays, just image overlays at a location. And you've got different map events like camera change, marker, it's not market tap, it's marker tap. And it does require an API key, so this is where you get your key for this. Beyond this, in terms of geospatial services, if you look at the key ones like OpenStreet, Google Maps, Microsoft, and Esri, for example, if we look at Google first, all the limits they give you are considered to be courtesy limits. Okay, so unless you actually pay them anything, don't take for granted what you will get from them. If your app becomes very popular, chances are you're going to have to start paying Google some money for that API use. But if your app is very popular, I hope you know how to monetize it so that you'll be able to afford those fees and still keep some money on top. So for example, the Google Maps API, you can do about 25,000 requests per day. Remember, this is for the key itself, not per user. Then geocoding API is 2,500 per day. The place search API is about 100,000 per day. And you can do no more than 1 request per second per user. So don't go writing a script that's going to try to geocode an entire database, because they're going to pick it up on this and then they can start like shutting you down. And then Bing Maps actually has some free services. A lot of people think Bing Maps is only a paid service, but they actually support free use on mobile. So if you create a mobile key on their Bing Maps portal, you can actually get up to 50,000 transactions per day for mobile. And then you can do geocoding because they have a batch geocoder where you can send a whole bunch of entries online. So you can do 5 batches of 50 geocodings per day if you want to geocode your data. If you're doing an evaluation, it's about 10,000 transactions for 30 days. And in any case, you are not allowed to create a turn-by-turn navigation app. So that means you're not allowed to use the maps and the route while at the same time tracking where the user is going to update the map. So you're not supposed to do this. Technically, you can do it, but legally, you can't. Esri is all paid stuff, but they do have a lot of free base maps that are great. So you can take a look at that, and I got some links at the end. And in OpenStreet, again, their policy is only 1 request per second. It has to be a single thread, no single machine, no scripts, no bulk geocoding. You need to give attribution to OpenStreet in your app. But there is a no-limit version that is run by MapQuest, which is the same API. It's called the no-minitum geocoder. So that was the demo I showed. Some libraries that are referenced, I covered this. There's some that I removed. I was going to use some of our stuff, like to show grid of results, but I decided to skip that for the demo because I knew I was going to run out of time. But make sure you come and check me out at my booth. I got some information about Nucleus. It's basically the best iOS controls for developers. We have a grid with tons of features. These are just like some of the things you can create with our grid. It could be a layout view. We have charts more than anyone out there, so come and check out our awesome charts as well. I'm going to skip through this. And finally, so you know where to get started. Developers.google.com/maps is for Google Maps. Esri is right there. Don't forget Windows Phone and Bing Maps on the Windows side of things. And then you can get access to additional libraries from us over there. Tomorrow, Wally McClure at 1:30 is going to do a session on iOS and Android. So he's going to cover the map kit, the Apple Maps side of things. And he's going to cover more on location services. And he's also going to have some content on Android as well. So we talked to make sure that you would get value out of both sessions. And this is a bunch of reference links that you can get when you download the slides. So JSON to C#, a bunch of links about Google Maps, OpenStreet, Bing Maps, and Esri. And that's it. So what you need to remember for now is activenik.net. That's my blog. Is there an evaluation format here or something? I don't know if there is. No? Really? They don't want to know? I'd love to know. So you know what? Ping me on Twitter. Let me know how you loved the session. So @activenik on Twitter. And let me know if the session was valuable for you. I'll be posting the slides and the demos on my blog so you can get started and play with it. Let me know what you build. I would love to hear more about your experiences with maps. And that's about it for me. So thank you very much. I'll be outside if you want to ask me some questions. I'll let you go on break for now. And I wish you a great rest of the show. Thanks, guys.